Right. Moving away from functions, we covered the main exercises on related to functions, and we're gonna go back to a particular type of functions like quadratics, cubics function, um, which in general are a part of a family of polynomials. With polynomials, a little bit of technical language that you need to be reminded of. So a polynomial function, it will be in terms of the one variable, which is as a standard is x, and your x term will be raised at different powers. So here the powers will be from the highest, which is n. It goes down by 1 up to power of 1, and the last one is a power of 0. So the highest power n, it has to be non-zero. Usually will be positive. We'll stick to positive for now. And when the power is equal to n, that's what we call the leading term, which is the term of the highest power index of the with a non-zero coefficient. So if obviously the coefficient in front is 0, then it will be the next lower power. That leading term is also telling you that the degree of the whole polynomial, all the terms, is the same as the value of n. Okay. Also, still around the leading term, if a n is equal to 1, it's called a monic polynomial. The same as when you have a quadratic. If it's a monic quadratic, the x squared term has a coefficient of 1. Talking about terms, the last term that has no x, which is actually x to the power of 0, a0 is what we call the constant term, as it is independent from x. Alright, what else do we need to know? I think that's about it. The last one. 0, so if the whole function was equal to 0, that's what we call a zero polynomial, which is a particular situation. Alright, let's move on. Okay, a few operations you need to be familiar with. When you do a sum of a difference, what you do is you look at the like terms and add or subtract the coefficient. Now, what's important to keep in mind is when you do the sum or of two polynomials, and the same as you do difference, the new function will take the degree of the highest of the polynomial. So for example, between p and q, the degree of p is 3, the degree of q is 2, the highest of the two is 3, so the degree of the sum or the difference is going to be 3 as well. Okay. For the product, when you multiply two polynomials, the degree of the resulting function of the product is you just add the degrees of each one of them. So if I was to do the product p and q, degree 3 and degree 2, 3 times 2 is 6, the product will have a degree 6. So here with part A, the example, so you just regroup the like terms and just add respectively the coefficient. Pretty straightforward. Have a look in the textbook for the difference. Okay, so let's look at the product. As I mentioned before, we look at the same example. The degree will be 6. Okay, so with the product, what you do is you expand, you multiply. So usually you want to be systematic. So what you do is you look at the first bracket. Let me get a laser before this disappears again. So you look at the first bracket, stop at the first term, from the first term multiply with every what they did is they multiply with the whole second bracket, which is what they did here for each the first term, the second term, and the third term. So there's a second term and the third term, and in the bracket is going to be the rest, the second bracket, and then they expand it again. um, Something that is probably straightforward, but you have three terms here, you have three terms there. 3 times 3 is 9, so when it's fully expanded you should have 9 terms over here. Okay, and then what you need to do is regroup the like terms. So you should have I just realized I made a mistake here. What I was mentioning before, and it's degrees 3 and 2, it's not times. To find the new power is you add the degrees, so 3 plus 2 is 5, not 6. So the highest, the degree of the product is going to be 5. So the formula was correct, but what I said earlier was wrong. Okay. Regrouping the like terms, so here they regroup the like terms and then they simplify and they end up with the product answer. All right, this is another strategies to a different strategy to expand that. Okay, so here is also mixing up simultaneous equations. So here find the values of b, c, and r. So you have three unknowns. You have a polynomial which is should be equal to that new expression, which is a product of 2 plus a constant. Okay, and what you're going to do is evaluate that, regroup the like terms, and as it says, two polynomials, they have to be equal only if all the corresponding coefficients are the same. Okay, wait, all right, just give me a sec. All right, so looking at the form that is has a product, you will expand each term with the second bracket, regroup the like terms, and what you would get is matching with the original equation. Alright, so we're gonna match that. The first term is 1, but the second term, b minus 2, needs to be equal to 3. This one needs to be equal to 2, and that's the constant one, so negative 2c plus r has to be equal to 1. First equation gives us the value of b. We substitute in the second equation, that gives us the value of c. Alright, and then we can get the value of r. So we have the three values, b, c, and r. We can insert them back into our original factorized, polynomial, a combination of polynomials. And here is that example done. Okay, something to link back to the Pascal triangle is how do you expand a binomial term to raise to the power of n. So if it's squared, it's a squared plus 2ab plus b squared. And let's look at the further down the road. You have power 3, you have that expression, 4, and so on. Okay, now with the coefficients, that's a 1, the last one is a 1, and here you have a 2, 3, 3, 4, 6, and 4. They are all based on the Pascal's triangle. Okay, so it's something to remember. Also, it links back to binomial distribution. With the combination, we get the NCR coefficient have this, they follow the same formula. Okay, so there's a little bit of a relation with the some of the previous topics. Okay, now before we move on to divisions and long division of polynomial. Let's look at how do we do a long division of 274 divided by 13. So this is the way you would set up your long division. Okay. Um, Also, what we can say is by rewriting this, it's also 274 is 13 times 21 plus 1. Okay, so that is the variation of how to write this. And then a little bit of a language. So 274 is what we call the dividend. What we divide by is the divisor. As you resolve your division, 21 is your quotient and 1 is your remainder. Okay, so just to remember those first three terms that will be constantly be used. Remainder, usually it's very common, you all remember what it is. Okay. um, Also, if the remainder is equal 0, so let's say I cross off that remainder, you can say that the divisor is which is 13 is a factor of the original number, which is the dividend. Okay. Similarly to basically the quotient, the divisor and the quotient are both factors of the dividend. All right, how do we apply this to a polynomials when we want to do a division of them? Here is the way we set this up. Okay, so or we write our dividend here from the highest order. Just do not forget, if there's some missing term, you need to insert them with a coefficient of 0. Here is our divisor. And how do we figure this out? We compare the start of the divisor with the leading term. Okay, it's a coefficient of 1, so we need to multiply by x, which is what we have. Or the other way around is you can divide x squared by x. That gives us the x value. Then what you need to do with that x, you multiply by x minus 2 and you write the answer here. Okay, then what you need to do is subtract that from the whole the original dividend. Hang on, something I want to add. Let me change to a pen. What I like to do though is when you do a minus, don't forget to put brackets. Okay, so here there's a 0, so you bring that down. Another way we used to do is to bring down that number down, and that's fine. We subtract, so that gives us 0, which is what we want. Okay, but the next one, don't forget, there's a minus with a negative or double minus. That gives us a plus. So as we have 9x plus 11, now what we need to do is with that 9x, we divide by x. That gives us plus 9. And then we do a multiplication of 9 by x minus 2, which is what we do here. We write the answer below, and then what we do again, we subtract all of that, and that gives us a 29, which is our remainder. Okay, then we can rewrite this. So that fraction, which is a division, it's our quotient. The quotient is x plus 9 plus another a proper fraction, which is our remainder over our divisor. Okay, we could also rewrite this as a product, but I'll skip that for now. All right, now let's look at long division of polynomials with a general kind of context. So what we want is we want to divide. Let's go back before polynomials. When we want to divide a number p by d, that's our divisor. So p is our dividend. We want to obtain two integers. One is going to be the quotient, which is going to form a product. And a remainder. From the previous slide, it's also, when we do a division, P over D is equal to Q plus the remainder over D. So this equation, it's similar to that one. Okay, so when you have 27, it's when you divide, you're trying to divide by 4, it's times 6 plus 3. Also a reminder, if our remainder is 0, and we can say that our divisor is a factor of P, or Q as well is also a factor. So here we have our D and Q. Because our remainder is 0, they're both factors of 24. Okay, so now we generalize that to polynomials. So they're going to be functions of x with terms of different powers. We divide a polynomial p by a polynomial d. We're going to end up with the similar expression as above. Let me hold on. So d is what we divide by, yes. So the quotient is what we get here, and the remainder. They're going to be both functions of x. Okay. Again, if the remainder, or r of x, is 0, then it will be a factor. Now, if it's not 0, what you need to know is it will have a degree less than the divisor. Okay, so it's the same idea as what you have here. When you have a proper fraction, it will lead with a degree that is smaller. So again, to define, P is our dividend and D is our divisor. Okay, so let's practice that with a long division. So probably a good idea to pause the video, have some space to set that up. Okay, so with your dividend and your divisor on the left, and try to do a long division yourself. Okay, here is the working out. Those are the instructions, or the step-by-step that is done at every stage. Now with every step that is you have a subtraction, don't forget, I do like to do this just so you don't forget, you don't make a mistake along the way. Okay, alright, so if you want to study the solution, just pause the video. Alright, here's another one. Again, pause the video and have a go at this. And again, similarly to that, I know the explanation is very long, but every dot point is highlighting what you need to be doing. So if I do, let me do the first three as it gets repetitive. You look at that leading term, you divide by x, that gives you 3x squared. Alright, and then next step, you're going to multiply that 3x squared with the divisor. That gives you 3x cubed minus 6x squared. The last step, you're going to subtract. Again, I like to do this. As you subtract, that cancels, the first term cancel out. Next one is 6x squared, x, and minus 3. Alright, and that was this part, and then you repeat until you can no longer divide, and the last number is going to be your remainder. Notice it's a constant, so that's degree 0. Your divisor is a degree 1, so you can see it's less than the divisor as a degree. Okay, now I think this is, hang on, okay, let me go back to this. The title is behind. This is a kind of different strategy to determine, instead of doing a long division. Very useful when you deal with cubic and quadratic, so very small polynomials. Okay, if it's an order degree higher, you wouldn't do this technique, that would be too long, you would just do a long division. But here we have degree 3, here is degree 1. Okay, what it means is the quotient will be degree 2 and your remainder will be a constant. Okay, the quotient being a degree 2 is a polynomial which is in the form of ax squared. So your remainder is constant, so it's one term. If it's quadratic, it's 3 terms. It's ax squared plus bx plus c. But we can get rid of the a is because x squared times x is equal to x cubed on the left. So the coefficient has to be 1. So that's 1. That's a 1. Therefore, a has to be 1. So we just getting rid of one unknown by quickly creating a mental equation of the leading term. All right, now what you need to do is from that you're going to expand it, and you have 3 unknowns, b, c, and r. 3 equations, 3 unknown simultaneous equations that you can resolve, and it will be a different way and sometimes quicker than doing a long division. So as I said before, we did the leading term already. Now we're going to move on to the x squared term, which has a value on the left hand side of -7. To evaluate the right hand side, to get the x squared is going to be, how do we get that? It's the -3 times x squared and the bx times x, and that's combined, that's over here. They combine the coefficients together, and that needs to be equal to -7, so we get b equals -4. Then you move on to the x term, which is a value of 5. You identify the products that gives you the x terms, which is the 12x and the cx. So 12x is coming from the b, so it's the bx times -3. That's how you get the 12x. And the cx is coming from c times x, and then we get the value of c -7. So as you go along, we have the value of b and c, substitute back into here, and then to find the constant term is we need to expand that, multiply that -3 with c, that gives us 21, plus r has to be equal to -4, which is what we have down here, and r is a value of -25. So here is an alternate method to instead of a long division, to determine the remainder and the quotient. And the alternate way, instead of writing a division, so that's your divisor times your quotient plus your remainder. Alright, so using that technique, have a go at solving this example. Don't use long division, just use that method. And we go pause the video and we'll come back to this. You should get exactly the same. Okay, so here on the left is the long division method. Okay, so here, hang on, the remainder is here. I really don't like when they use mixed numbers. They should have left it as improper fraction. Now the difference you're gonna get here on the right hand side, so you have your dividend here. Here is our divisor, or quotient has to be a quadratic because this is degree 1. So 1 plus 2 is 3, and a remainder has to be less than 1, so it's a degree 0, which is a constant. Okay, and then you're gonna have to equate the terms, so the x cubed term from the left with the right. So the process here on for the right is just the 2x times ax squared, so we get the a value. Substitute the a value straight away into your equation. Then move on to the x squared term, so the left hand side is 2, the right hand side will be this one times a, and the bx and 2x. I know they form the x squared term because x times x from your index flows gives you x squared. Okay, so you need to practice that mentally. Again, if you're not sure with that, the long division probably will be the way to go. Okay, as you continue, then you end up with all the by solving all the unknown a, b, c, and r, and it will get the same answer as the left hand side. Okay, now let's say you divide now by a nonlinear polynomial. Similar process. Okay, so long division. Now what's here is missing is there's no x term, so I would, good habit, you have to do that for your divisor as well as your dividend. Okay, so scan across, you have an x cubed, x squared, x, and constant. Okay, so don't forget to add 1 with a 0 coefficient for the x term. Okay, then with the process again, you take that term, divide by x squared, that gives you 3x. With that 3x, you multiply with everything here, that gives you that new term, and now we will introduce an x squared term with a 0 coefficient, so everything is lined up. All the like terms are lined up. Once they're lined up, you can subtract. Don't forget, I like to do this. Same here. You bring everything down. Oops, sorry, bad habit of doing this is is all the way. Finally, you end up with the quotient of 3x minus 2. That's your remainder. So our dividend on the left hand side is equal to our divisor here times the quotient that's coming from there plus the remainder. Again, notice how the remainder has a degree 1 and the divisor has a degree 2. Okay, and I think that's it. Just give me a sec. Alright, so that was it for today's exercise 6a and 6b, and I'll catch you later.